Take out your pencils and notebooks. Everybody should be working quietly on the do now activity. We're just going to wait a few more moments for everybody else to come into the class. All right, it looks like everybody's here. I want everybody to take a seat. We're going to get started with our lesson. Today's topic is Introduction to the Laws of Exponents. And we have 4 class objectives. We're going to learn to read the terms, learn the 3 definitions that will be important to the laws of exponents. We're going to introduce a lot of the laws of exponents, many of them. We're not going to learn all of them, we're not going to memorize them all today, but we're going to be introduced to them. And then we're going to practice these on some pretty complex problems. We're going to show how we use to simplify these complex problems. Okay, everybody should be done with the do now activity. So we're going to move on to our first class objective. Learn to read and talk about exponents. So a very important place to start is a definition. Exponents are also called powers or indices. The reason we start with this is because we're going to be using powers a lot to refer to exponents. Okay? This is the exponent. This is the base, a. This is the exponent, 7. So we can read this as a to the power of 7, or a to the 7th power, or a to the 7th. Okay, we're going to show another example right here. Again, we have the base and the exponent, and we can read this as 2 to the power of 7, 2 to the 7th power, or just 2 to the 7th. Okay, so now we have, does anybody know how to read this exponent? Okay. Well, good guess, good guess. It is 2 to the power of 2, but we can also say 2 squared. Okay? Does anybody know how to read this exponent? 2 to the power of 3. Good try, good guess. Good guess. Anybody else? No? No one's read ahead in the book? 2 cubed. And I'll explain tomorrow. We're going to do a different lesson and we'll explain why these special terms are labeled this way. But now let's do some practice. John, can you read this exponent for me? 2 to the power of 4. Good job. All right, Jamie. How about this exponent? 2 to the power of 7. Good. And Samantha. Yep. This exponent. Yep. 2 to the power of negative 7. Good. Is that what you said? Yep. Okay. So now we've learned to read and talk about the exponents. That's a very important first step. We can move on to our second objective, which is learning 3 important definitions about exponents, about 3 different types. First definition, we're going to talk about basic exponents. The exponent says how many times to use the base number in a multiplication. So a is the base, 7 is the exponent. A to the power of 7 equals a times a times a times a times a times a times a. Another example, 2 to the power of 7 equals 2 times 2 times 2 times 2 times 2 times 2 times 2. Anybody tell me how to write out 2 to the power of negative 7? John? No, that wasn't a hand? No? Okay. Well, that's our second definition. A negative exponent means to divide, because the opposite of multiplying is dividing. That's how we can remember it. So a to the power of negative 7 is, this is one way of writing it out so we can think about it. 1 divided by A, 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 divided by A. A simpler way of writing it out is 1 over A times A times A times A times A times A times A, 7 A's. So Samantha, can you tell me how we would write out 2 to the negative 3? If we use this as our model, there's 7 A's under 1. Yep, good job, good job. 1 over 2 times 2 times 2. Now, we're going to get to fractional exponents. Does anybody have any idea how we would write out this? You think you know, Jamie? You think you know? Well, it's okay. It's okay. We're getting to the definition here. A fractional exponent, like we just saw, means to take the nth root, take the exponential root of the base. That means a to the power of 1/7 equals the 7th root of a. Another example, 2 to the power of 1/5 equals the 5th root of 2. So this is a review of the 3 definitions. I want everybody to make sure that they have these definitions and the examples written down somewhere in their notebook, because these will show up on a test and they're very important. First definition, the exponent says how many times to use the number in a multiplication. So John, if I had 2 to the 3rd, yep, that would be 2 times 2 times 2. Good, here we have 2 to the 7th. A negative exponent means to divide, because the opposite of multiplying is dividing. So we've written it out 1 over 2 times 2 times 2 times 2 times 2 times 2. Third definition, a fractional exponent means to take the nth root. This is the same example. 2 to the 1/7 equals the 7th root of 2. Now, if everybody has all these written down, we can refer back to them when we're doing our practice problems. Okay? We're ready to move on to laws of exponents. Does anybody have any questions about what we just learned so far? Yep, those definitions will show up on a test at some point in the next few weeks, so it's good to try to memorize them. Yeah. So these are the laws of exponents. What I'm going to do is take this sheet. It's okay, it's ripped a little bit. And I'm going to put it up on the board here for the next few days so that we'll have it as reference. But it'll also be a good reference to have just for class today. Can everybody see this sheet? Good? Okay, so Jamie, I want you to read this first exponent. X to the power of 1 equals x, right? Samantha, the second exponent? X to the power of 0, or x to the 0 power, good, equals 1. These are definitions. So, John, can you tell me what 5 to the power of 1 is? Yep, it's 5. And how about 1 million to the power of 1? Yeah, it's 1 million. So, David, how about 5 to the power of 0? 1. Good. 5 to the power of 0 is 1. How about David, again, 1 million to the power of 0? 1 million to the power of 0 is 1 also. Good job, David. Okay, these two are very important. You can also see that this exponent is similar to the definitions. It's a negative exponent. So we divide 1 by x one time. We're going to be referring to these while we do our practice problem, but it's time to move on and to see how it applies, how we can really use these exponents. these laws of exponents. So, our problem is here. We've given a complex fraction, numerator and denominator. We want to simplify this term, this complex term, into this more simplified term, which is just x to some power times y to some power times z to some power. There's two methods we're going to use. The first one, we can solve the numerator and then solve the denominator and then divide the numerator by the denominator. The second method is we're going to group all of the like terms as quickly as possible, all of the x's, all of the y's, and all of the z's. And then we're going to apply the laws of exponents to them. Let's see how this works. So the first method, we're going to take the numerator out. We're going to group the like terms. We're going to group the x's, this is y and a z term, and we're going to apply this law of exponents, x to the m times x to the n equals x to the n plus n. See how it works here? X squared times x to the 6th equals x to the 2 plus 6 equals x to the 8th. So this term equals this term, so we can substitute it, this term, for x to the 8th. And we've simplified our numerator. We can't go any further than this for now. Now we're going to look at the denominator, z to the 6th times y to the 4th times xz to the negative 3rd. We're going to try to group like terms, but first what we have to do is we're going to separate the x and the z into x and z by applying this law of exponents. X times y to the n equals x to the n times y to the n. You can see how this works here. X times z to the negative 3 equals x to the negative 3 times z to the negative 3. So we substitute in this term for this term because they're equal. That's how this becomes this. Does everybody follow me? Okay, we're going to have time to answer some questions after we finish this problem, okay? But I don't see any hands right now. We're going to group the z's together, y and x term, and we're going to apply the same law of exponents that we already did, the multiplier law of exponents. So we can see that z to the 6th times z to the negative 3rd is z to the 6 plus negative 3, or z to the 3rd, z cubed. And we can see that this term equals z cubed. So we can substitute the z's for z cubed. We can't go any further than this. This is 1z, 1y, and 1x term. This is our denominator. So at this point, we've simplified the numerator, we've simplified the denominator. So we're just going to group the x's, group the y's, and group the z's, just switching around the z and the x in the bottom. And now we can see that we can apply the same law of exponents in all these three cases. So x to the 8 minus negative 3, x to the 11th. Y to the 4th over y to the 4th equals y to the 4 minus 4 equals y to the 0. What does y to the 0 equal? David, you should remember this. Yep, 1. And z to the 9th over z to the 3rd is z to the 9 minus 3 is z to the 6th. So we can substitute these for these terms up here to come up with our simplified answer, x to the 11th times y to the 0 times z to the 6th. Y to the 0 becomes 1. And then we have our final answer, the most simplified form. So, I know this is a lot right now. We're going to be going over a lot of the same laws with the second method. Now, in this method, we're going to group all of the like terms together. We're going to group all the x's, the y's, and the z's as quickly as possible. And then we're going to apply the laws of exponents. So, first, we take all the x's from the equation, we separate them, take all of the y's, all of the z's, and then we have this xz term. So now that we have everything grouped together by like terms, we can apply the laws of exponents and see that x, y to the n, we can simplify each one of these terms into one x, one y, one z term, and separate this out into one x and one z. So first we're going to separate out the complex term. See that xz to the negative third, if we remember, it's x to the negative third times z to the negative third. It's this law right here. And from here, we just substitute in this term for this term. So we jump from here to here, substitute in this for this. And now we can separate this fraction into one x term and one z term. It's like 1/6 is equal to 1/3 times 1/2. Right? Okay. So now we can regroup the like terms. We just have x's, y's, and z's. So we regrouped the like terms, and now we can apply the multiplier law of exponents. X squared times x6 equals x to the 2 plus 6 equals x to the 8th. Z to the 6th times z to the negative 3rd equals z to the 6 plus negative 3, or 6 minus 3, z cubed. So we substitute in these two terms for these two terms. See how we've simplified it here? Is everybody following me? Yeah? Okay, so now we can apply the same law of exponents in all three of these cases, which is x to the 8th over x to the negative 3rd equals x to the 8 minus, because they're division, negative 3 equals, or x plus 3 equals x to the 11th. Y to the 4th over y to the 4th equals y to the 4 minus 4 equals y to the 0. What does this equal? It's a definition. Y to the 0. 1. Good. Z to the 9th over z cubed equals z to the 9 minus 3, or z to the 6th. And x to the 11th times y to the 0 equals z to the 6th. We get this by substituting these three terms for these more complex three terms. So we go from more complex terms with the law of equations. We get more simplified terms. Y to the 0 becomes 1. And then we have our most simplified form of the equation, or form of the term, right here. Both methods have gotten us the same answer. So you see there's not just one way of answering the same problem. Okay, I know that everybody looks pretty confused right now. We just crammed in a lot of content. It's just an introduction at this point. We're going to do 3 or 4 more problems together. So at the end of class, hopefully you'll all be doing problems like this on your own. I'll be handing out worksheets. And I want you to learn both of the methods, but you don't have to use both of them in each problem. You can use whichever one you prefer. And as long as you just write out all of your work so I can see what you're thinking. That way, what might seem like a mistake could actually be a new third way of answering the question that I haven't learned or taught to you guys yet. So just make sure to write out all of your steps and copy all of the steps as I go over these other problems. So if you have any questions at any point, you can show me which step it is. Thank you.